Hello, everyone. This is Carl Freund with Cambrian-AI Research. Today's guest is Andrew Richards. Andrew is founder and CEO of a company called Codeplay. Many of you may not have heard of Codeplay, but many of the chip vendors around the world are very familiar with what Codeplay is doing to help them. Andrew, welcome aboard.
Hi, Carl. Great to be here.
Thank you.
Shame we can't be here in person, but let's do the video thing anyway.
We'll do the video thing. We're all getting very used to it, I'm afraid. The new normal. So Andrew, why don't we start off, tell folks about what Codeplay is doing, what you do with who your customers are, and what you do to help them with AI.
Yeah, so Codeplay we're really a development tools company. So we do compilers and programming models. And as the name kind of suggests, it was originally video game stuff. So I was a video game developer and I thought, let's do tools to do stuff with graphics processors. And I thought, maybe in the future, we could do all sorts of amazing things with graphics processors. And people did do amazing things with graphics processors, a lot more than I was expecting. And somehow here we are today building technology for supercomputers and self-driving cars, which was maybe a fantasy at the beginning, but it's something that's really happening now. We're based here, we're in Edinburgh, in Scotland, in the UK, but our customers are all around the world. And in COVID times, because we hire quite internationally, then we've got people all around the world as well.
Great. So describe the process. What does a customer engagement look like? How does it start? What does it end up delivering to the customer?
So it's interesting because we kind of sit between two worlds. So we sit between the worlds of the chip designers and the world of the software developers. So most of our customers today are chip designers. They're designing chips to do artificial intelligence or supercomputers. And they've designed their chip, it's kind of programmable, but it's very well optimized for certain kinds of tasks. And what we do is we make it so that you can use standard programming models on that chip. So you can make that chip programmable like a GPU, basically. So a lot of our customers, although we started with GPUs, a lot of our customers are not GPU companies. They're much more like AI chip companies, but we make that chip look much more like a GPU, and we make it easy to program. And our big vision is about industry standards. We're a big believer in industry standards so that you can write code once and run it everywhere. And so that's why recently we've had a lot of engagement from supercomputer sites. So for example, we're working with Lawrence Berkeley National Lab, who have bought a supercomputer based on NVIDIA GPUs. And what we do is we support the Sickle industry standard for them. And then that will enable people to write software on the NVIDIA GPUs and then move it to the Intel and AMD GPUs that are being used for the huge new exascale systems in the future. And we do similar things in other markets like self-driving cars and medical imaging.
So the mantra of write once, run anywhere has been around since I can remember, but it often had some significant performance limitations where your original target would perform quite well. And then when you move the code over with your industry standard APIs and compiler, the output isn't optimal. How do you resolve that issue? I mean, is that possible that you can be both write once and run anywhere and high performance?
Yes, it is possible, and we can prove it, right? Because there's all the supercomputer sites are writing once and running on different systems, and there's a whole load of data to support it. But you have to deal with reality, right? You have to deal with there's a difference between, okay, there's the magic, you write it once, you don't need to think about whether it's fast anywhere or anything like that. Okay, I'm not promising that. What I'm saying is it's going to take you less effort to tune your code for a new computer. That's the key thing, right? So what's interesting is a lot of this stuff did actually come out of video games. So we're seeing it with video games. It was harder to talk about it, but video game developers have to write code that's going to run fast on a PlayStation and on an Xbox and on a Nintendo and on a bunch of different PCs. So they have to write code that's both fast, because video game developers care about performance a lot.
Yeah,
really care about performance. Yeah. But they still have to write it once and run it on different platforms. So the way that you do it in reality, right, is that you do write it once, but you still have some performance experts who, what they do is they kind of give frameworks and libraries and ways of doing things to the most of the developers on thing, and then they'll tune those frameworks for different systems. Right, that's the reality, and we're seeing that in supercomputers. And the great thing about supercomputers is that they write lots of papers on it, but it's all based on C++. And the truth is, it's not really magic. It's the C++ programming model. It's just kind of supercharged a bit.
Can you spend just a few moments giving us a one-on-one introduction to Sickle? What is it? Many of our audience may not be familiar with Sickle.
So Sickle is an industry standard. It comes out of the same industry standards body as OpenGL and Vulkan and OpenCL. The difference is Sickle is an industry standard that really takes this C++ idea and enables it to run on lots of processors. So NVIDIA has been very, very successful in their CUDA programming model, and slightly later versions of CUDA got quite good at this C++ approach. So you could write code in C++, interestingly, in CUDA, but also run it very fast on your CPU. So you could use this C++ technique of saying, I've write the code once, it'll run fast on my CPU, and actually the same code pretty much will run fast on a GPU. A really good example of this is like the TensorFlow AI framework. It has a library in it called Eigen. So Eigen is a library that uses these C++ techniques. And if you invent some new AI operation, you can write it using Eigen, which is just C++, right? It's not magic. It's using C++. But Eigen, using C++ techniques like templates and things, will adapt your code for a CPU, and it will adapt your code for a GPU. And what we did with Sickle is we said we don't just want to do this on GPUs, and we certainly don't want to do this just on GPUs from one vendor. We want to standardize this technique. So Sickle it's much less explicit about the hardware. It's more of a data flow programming model. You can extract different ways of handling data. It kind of allows you to control the data, but it still allows you to take this C++ technique and apply it to a very wide range of processors, whether it's a GPU or CPU or even an FPGA. And for us at Codeplay, there's quite a lot of DSPs aimed at AI we applied to as well.
Interesting. So it seems like this would be a boon to the industry where a new AI hardware startup comes along and says, I've got a new chip, I need to be able to run all these applications efficiently and at very little porting cost to my customers, but also for companies that have sort of a domain-specific architecture strategy where they have multiple architectures designed to solve different problems optimally. Am I getting it right?
Yeah, exactly. And that's exactly what it's designed for. So for example, Intel adopted the Sickle industry standard for their OneAPI. So OneAPI is it's Intel specific except a lot of it's open source, so you could bring it to new hardware, but it's based on the Sickle industry standard programming model. And Intel describe it as their XPU strategy, X meaning any processing unit, so you can move stuff around. But it's very much designed so that if you've designed your own processor, you can just take the program model. It's a royalty-free industry standard. You can implement it, or you can take some of the open source code, or you can come to Codeplay and we'll charge you some money, but we will build a lot of it for you and we'll provide some tools. But you have all of those options. You have all of those options. Recently there was few students in Japan decided to take the Sickle industry standard, and they implemented it for the NEC vector processor and got fantastic results in a very short space of time. Really, really good results. So it's an absolutely fantastic boon. If you're an AI processor vendor, you're going to be thinking, but is it going to be optimal on my architecture? And my answer to you is, there's nothing about Sickle that stops you from adding in your own customizations. Just like Intel has done with OneAPI, you add in the stuff that you're really good at. If you've got a really fast convolution unit, you want to use that, right? You don't want to get your programmers to write convolutions. And to be honest, no one wants to write convolutions, right? But all of that other stuff, all of the new operations, all of the stuff that's done by researchers, all of that will work in Sickle, and that can be mapped to your data flow architecture or whatever it is really, really well.
Wow, that's interesting. So, just recently, MLPerf released its inference benchmark suite, version 1.0. And I wonder, does Codeplay get involved in helping AI hardware companies optimize code for benchmarks?
We do, but you know, I can't answer all questions. Yes, I'd love to tell you which. I'd love to tell you which benchmark results are aided by Codeplay, but I can't do that, unfortunately. But certainly, that's one of the things that we do. We help people get performance.
Good. So for those of you listening who are building your AI chips and need some help with optimizing your benchmarks, you might want to give Andrew an email, phone call, and see what maybe he could do to help. But you know, I think that's great because it sounds like you're very focused on industry standards, open software, which is just critical for enabling us to leverage all the great research and development work that's being done around the world. I saw an article this morning that said that last quarter there were 37,000 openings for AI engineers. So we've got to do something to help the workforce be more productive, especially when the industry is still in lots of different architectures out there.
I do think industry standards help all of this. So for example, 37,000 people, they can't learn a programming model that's different for every different processor, but they can learn C++, probably know C++. You can hire C++ developers, and so you can train them up in Sickle very, very quickly. And I do believe that it's a really fast-moving field. There's constantly new ideas and new things coming across. So enabling researchers to come up with new ideas, I think, is really important. And I think openness is great for that. I'm just really excited about all of the new innovations that we're enabling.
That's awesome. That's excellent. Excellent. Well, I think that's all the questions I have. But if you have anything else you want to add that I perhaps forgot to ask, take a shot at it.
Yeah, I just want to say, you're all about this Cambrian-AI explosion. So all of these different AI processor architectures. I think, it's fantastic that there's all this innovation. I really do think that for a lot of them, you should really look at these open standard programming models, because you're going to see stuff that's just going to be a bad fit for your processor. But that doesn't matter, because as long as most of the stuff works, you're then going to move the code onto that processor that's right for it. And you're just going to find it so much easier to get people to adopt your processor or develop software for your processor if you adopt an industry standard programming model. It's just going to make your life so much easier, and you're going to move much faster.
Well, it's all about speed, both in terms of the processors and in the execution of these.
And I have to say just one more thing.
Please.
That is, the people out there, innovators, are crying out for these new processor architectures. They want to see it. Software developers out there building these systems, they've come up with new ideas that need lots of new performance. I know this because this is like the video games industry when we were like 8-bit things. It was crying out for graphics processors to come along. Same in AI. There's people crying out for new AI processors, but you've got to think to yourself, these people are innovators. They're designing new AI algorithms, and so that's why it's so important to enable these people with a programming model where they can bring their new AI algorithms to your chip. That's where the market is. That's where the opportunity for these companies are.
Excellent, excellent. Great thoughts, great advice for our audience. I look forward to watching you be successful in getting the industry software to be open, accessible, and high performance. A hard set of equations to solve, but it sounds like you're on your way and helping customers deliver just that. So.
Yeah, we are, and we didn't even start on the subject of how you make all of that safe to actually drive a car. But that's right. Maybe for our next video is another challenge.
Let's do another session on that topic and more. I enjoyed talking with you, Andrew, as always, and good luck and stay in touch. Thanks, everybody.
Great.
Bye-bye.